Now let's see how we can derive this marginal rate of technical substitution by taking partial derivatives. Remember that the marginal rate of technical substitution is the slope of this isoquant when you have L and the horizontal axis and K on the vertical axis. This slope is a marginal rate of technical substitution, and we have proved in the previous video that that's going to be equal to the ratio of the marginal productivity of labor over capital. So since you can take the marginal productivities by taking partial derivative kind of in the same way that you did for consumer theory to take marginal utilities, this process becomes kind of straightforward. So to take the marginal productivity of labor then, we can take the partial derivative of Q with respect to L, and that's going to be equal to L, A minus 1, K comes out as a constant with a B exponent, and then the marginal productivity of K is going to be equal to the partial derivative of Q with respect to K, which is going to be B, the L comes down as a constant, K, B minus 1. We're looking for the marginal rate of technical substitution, so we're going to put the marginal productivity of labor over the marginal productivity of capital. Now we just have a term for the marginal productivity of labor when we took the partial derivative up there. That's this. And we also have a term for the marginal productivity of capital, which is the term that we just calculated after that, which is this one. Now by using rules of exponents, we take the L to the power of A minus 1 and bring it down with the opposite sign, and we take the K to the raised to the B minus 1 and bring it up with the opposite sign. We end up with the following expression. And that is going to be the ratio of the marginal utilities of labor to capital, which is the marginal rate of technical substitution. When you have a production function, a Cobb-Douglas production function like this one, it's always going to be this. So it's a pretty simplified expression for the marginal rate of technical substitution. Every time you have an equation like this one, if you want to find out what the marginal rate of technical substitution is going to be, well, it's always going to be equal to the ratio of the marginal productivities, which we now prove that it's always going to be equal to AK over BL. Okay, and this is going to be very useful shortcut when you're doing the minimizing costs when you have prices of labor and capital.